Hi, I would like to define multiplication of a fraction by a whole number. Let's begin by reviewing the definition of multiplication of two whole numbers. So by definition, 5 times 7 is 7 plus 7 plus 7 plus 7 plus 7. So in other words, if you're adding 5 number of 7s together, this is the expression that says that you're adding 5 number of 7s, and what we're saying is a shorthand notation for this same expression is simply 5 times 7. We can also use the following words. 5 times 7 is 5 copies of 7 to indicate 5 times 7 by definition is 7 plus 7 plus 7 plus 7 plus 7. And if you want to know which whole number is 5 times 7, you would add these 7s together and you know what that whole number is. I would write it down. So similarly, 3 times 10 for us by our definition of multiplication is 10 plus 10 plus 10. This is a shorthand notation for this expression. And so we will sometimes use the words 3 times 10 is 3 copies of 10. So we'll keep these definitions of multiplication of whole numbers in our mind, and let's now look at how to define multiplication of a fraction by a whole number. So keeping the definition of multiplication of whole numbers in our mind, we look at this expression, a whole number times a fraction, and we ask ourselves, what would be a reasonable definition for this expression? What could we think this expression to mean? What meaning could we give it to it? And if we remember how we define multiplication of whole numbers, we might say we would like this expression to mean 3 over 7 plus 3 over 7 plus 3 over 7 plus 3 over 7 plus 3 over 7. In other words, we would like 5 times 3 over 7 to mean 5 copies of 3 over 7. So in other words, look at this expression. This long expression, 3 over 7 plus 3 over 7 plus 3 over 7 plus 3 over 7 plus 3 over 7, we would like this to be a shorthand notation for this long expression. Now let's look at this long expression. Do we know how to evaluate it? In other words, do we know how to add 5 number of 3 over 7s? Yes, we do. From addition of fractions with the same denominator, we know this expression is simply another fraction, a fraction whose denominator is exactly 7, same as these denominators, and its numerator is simply adding these 3's together. How many of them? 5 of them, and that is simply 5 times 3 in our notation, and that is 15 over 7. Okay, so in other words, from this, so this is really the definition of this expression, and from addition of fractions, we do know how to calculate this. It is 5 times 3 over 7, which is 15 over 7. So in other words, if you encounter this kind of an expression, a whole number multiplied by a fraction, what we are saying is, if you want to calculate what it is simply 5 times 3 over 7 or 15 over 7. How do we go from here to here? Well, this is what explains it. By definition, this expression really is 5 copies of 3 7s. And we know how to add 5 copies of 3 7s from addition of fractions. And that gives us 5 times 3 over 7, 5 times 3 over 7, which is 15 over 7. But it's good to remember this because this is what we want to use when we want to quickly calculate 5 times 3 over 7. We can calculate it to be 5 times 3 over 7. So look at the structure of it. So in general, we can take this as the definition of a whole number multiplied by a fraction. So let a, b, and b whole numbers and b not equal to 0. So a whole number n multiplied by a fraction. By definition, we can define this expression to mean this fraction a over b plus a over b plus n copies of them, n number of those a over b's added together. So from this definition, just like we did in the specific example, we can easily conclude this particular fact, that n times a over b is in fact the fraction n times a over b. How do we justify this equation? Well, by definition, n times a over b is this expression. This expression is simply addition of fractions with the same denominator b. So this expression is simply another fraction with the same denominator b, and its numerator would be a plus a plus a, n number of those a's added together. In other words, n copies of a. N times a is really the expression for n copies of a. So this fact is worth remembering. It's simply justified from directly using the definition. So we'll now keep this in mind and do a few computations. So using the fact that I just mentioned, a whole number multiplied by a fraction is simply a fraction, 11 in the denominator and 8 times 3. So this is same as 24 over 11. So 8 times 3 over 11 is same as 24 over 11. Let's do the same for this. So here we have, using the fact, 3 in the denominator and numerator is 5 times 1, which is 5 over 3. So let's look at this, which I will rewrite again. So what we are concluding is 5 times 1 over 3 is 5 over 3. Let's look at this equation. So notice when we first introduced fraction, we referred to 5 over 3 as 5 copies of 1/3 or 5 over 3 as fifth multiple of 1/3. Now in this equation, you can really see that referring to 5/3 as fifth multiple of 1/3 is completely justified and matches with this. 5 times 1/3 is the fraction 5 over 3. So 5 over 3 is 5 copies of 1/3. You can think of 5 over 3 as fifth multiple of 1/3. And if you in fact do 5 times 1/3 using the definition we gave, it is really 5/3. So everything matches. Thank you.